Hello everyone, my name is Yashis from Team 18221 Meta Infinity in Trumbull, Connecticut, and welcome back to today's episode of MetaCast. Today, we are joined by a member of Team 18661, Davi. We are going to be going over an introduction to fabrication for teams in the FTC competition. Davi, welcome to the show.
Hey everyone, I'm Davi from Team 18661 Arc Flash.
So, to get started with this episode on fabrication, let's just have a couple questions on introduction to fabrication technologies. So, what are the key methods of fabrication used in FTC robotics?
Yeah, so a couple of them that are mainly used are CNC machining, laser cutting, and 3D printing. Those are the most commonly used ones.
Yeah, awesome. And then, how do those different methods, CNC machining, laser cutting, 3D printing, how does it contribute to the fabrication process for each team?
Yeah, so they all have their own part. CNC machining can lead to a really nice final product of your robot. 3D printing helps all around, can lead you to initial prototyping, final goal, all around does everything. Laser cutting can be used for prototyping all the way up. I've seen it done with final robots. So yeah, it definitely all helps just kind of get the robot together, get stuff tested, accelerate your season.
Yeah, definitely. Diving a little bit deeper into CNC machining. So, how does that work, and what is its advantages in FTC robotics?
Yeah, so with the CNC, essentially, uh, you have a 3D printer, but it's a lot larger. And instead of a hot end where filament would come out, you have a spindle in which something similar to a drill bit called an end mill is attached, and there from that you can cut out shapes and kind of make different things that you would never be able to do by hand. And all of that is done through a computer with custom G code that you write or you get written for you using slicers similar to Prusa Slicer and stuff for 3D printing.
Yeah, definitely. What types of materials should teams use for CNC machining?
Yeah, so of course there's a ton of them, but the main ones that I would recommend are 6061 aluminum. You can go down to 5052 if you want to bend your metal, but that's what I would recommend for aluminum. Then you can also machine wood, but there are more efficient ways of doing that. Another big one is machining polycarbonate, which is a type of flexible plastic that really can reform its original shape and is nice for side panels and stuff like that.
Yeah, definitely. And I've heard that some teams use carbon fiber for their robots. Is that CNC'd usually, or do they hand cut it?
Yeah, so typically what happens is teams will reach out to sponsors or manufacturing companies to get that done because while you can cut it on a CNC, it's very dangerous to do so as it produces a lot of dust that can really harm your lungs. So some teams have gone and machined it in water on their CNC, but that takes a lot of setting up. And if you want to machine carbon fiber, you might as well go find a sponsor or a company to do it for you.
Yeah, definitely. Moving on to laser cutting. So, how is laser cutting beneficial in fabrication of robot parts compared to something like CNC machining?
Yeah, so a big thing with laser cutting is with most typical lasers, you're able to cut plastics and different woods. The most common wood I've seen is MDF, which is a nice type of board that you can just cut really fast. And doing that allows you to rapidly iterate and prototype your different pieces of your robot so you can make an intake right away instead of just having to jerry rig it with some U channel or whatever. You can get a really nice prototype made, and you can even cut stuff on the laser cutter that will go on your final robot. And I've seen teams build their entire robot out of laser cut pieces. Our team, personally, we have a sponsor that laser cuts aluminum for us, but most lasers at school or at home will typically not be able to do aluminum.
Yeah. And then moving on, are there any specific design considerations teams should keep in mind when they're designing parts to be laser cut for their robots?
Yeah, so if it's going on your FTC robot, you want to make sure that it's strong because a lot of laser cut parts have been prone to snapping and stuff like that. So one thing that we did is when we prototyped with our MDF board, we ordered 0.25 inch instead of the common 0.125 inch, and that allowed it to be a lot stronger. And our robot was just able to withstand our testing that we wanted to do on it before we fully switch to metal. But one thing you do have to take into account there is in your CAD, you have to make sure that you have it ready to switch between different thicknesses of metal because I would not recommend using 1/4 inch aluminum.
Yeah, definitely. So moving on to 3D printing, how do you think 3D printing has revolutionized prototyping and production of parts in FTC robotics compared to, say, games or teams from 10, 12, 13, 15 years ago?
Yeah, so 10, 12, 15 years ago, of course, stuff like CNCs and mills were still available, but those took a long time to work on, and in FTC, they didn't really have an advantage of using them. So most teams just built fully COTS robots, which means they got all of their parts from a supplier, such as, say, GoBuilda, or at the time, Rev and Tetrix. And now with 3D printing, they have a lot more freedom to do whatever they want. Like, for example, this year, our team, we couldn't find a gear or a strong enough gear, so we decided to utilize our X1 carbon printer, and we printed these really nice herringbone pattern carbon fiber reinforced gears, and that allowed us to pivot our huge arm over our robot, and it worked a lot smoothly, and yeah, it was nice.
Yeah. What type of 3D printing technologies are commonly employed for teams this year? How do different 3D printers differ from each other? What do the filaments mean?
Yeah, so there's a lot of different type of printers. There's bed slingers, Core XY printers. Mainly the printer choice doesn't matter as long as you get the settings dialed in. Of course, I wouldn't recommend any of you teams going out there and getting $10,000 or $20,000 printers. There's a lot of really nice choices for under $1,000. Heck, even under $500 that are really nice for FTC teams. Like the new Bamboo Labs A1 printers that are coming out are really nice. Uh, the Ender 3 Pro is a nice option, but that takes a lot more work to get, to keep it running, although it is really cheap to start off with. But also, a 3D printer, it creates the part by dispensing filament, plastic filament, and that filament can either be brittle, tough, bendy, you name it. So the material choice definitely matters. Typically in FTC, all you're really going to need is PLA. That's the perfect balance between everything. And in the loads you're going to encounter in FTC, you're not really going to need anything more. If you want something, say, squishy, you can get some TPU filament. But if you do that, I would recommend you have a printer that's a direct drive filament extruder, because or else the TPU gets really messy and doesn't exactly print well.
Yeah. And then moving on to selecting your different materials or what choice of fabrication. So, what different factors would influence the choice that teams make when deciding what materials they want to fabricate for their robots?
Yeah, so one big thing is how quickly do you want to get your parts, how much money do you have to spend, and how durable do you want your robot to be. Like most teams that I've seen nowadays are going with aluminum parts. Uh, as time has gone on, that has gotten a lot cheaper with the addition of Fabworks and teams buying their own CNCs. I have seen teams go and buy carbon fiber, which costs a lot more, although the price has gone down with some recent new sponsors in the FTC game. Um, but yeah, some of the factors that influences is essentially how durable your robot is. Like, If you have a wood robot, of course, you're not going to be able to take as many hits as, say, an aluminum or a carbon fiber robot, although it's going to be a lot cheaper, and if you have a laser cutter, you can get that done right away. Uh, so yeah, those are kind of the main factors with that.
Yeah, and how do you think teams should balance the trade-offs between strength, weight, or cost when selecting their materials? Do you think there's something they should prioritize over the other?
One big thing I always think about is you don't want to ever cut corners. But if you're ever trading off between, say, getting carbon fiber plates or getting Mizumi slides instead of Rev slides, get something that's going to allow you to play the game a lot better. So, in that example, getting Mizumi slides, because of course a wood robot will always work. You might need to cut a few more plates here and there, but in the end, just go with whatever you think is best for your team. For example, with my team, we were able to get a lot of our robot manufactured out of metal, but that's because we have sponsors for it. Our robot ended up being a lot heavier because of that. So if some teams want to run a faster drivetrain per se, they might want to go with a lighter robot made out of, say, wood or carbon fiber.
Yeah, definitely. And then next up with design iteration and prototyping, how do you think Fabrication Technologies would facilitate the iterative design process in FTC robotics? Like, how do you think teams should go about using it, like innovating or iterating upon these different sub-assemblies or assemblies that they use?
Yeah, so with 3D printing and laser cutting, a big thing is the speed of how quickly you can iterate. Like, for example, one thing, if you do have the parts, is you can always start out the season by making a really quick robot out of laser cut wood. See how that does? You can learn a ton of lessons from that. Then you can just keep iterating from there, and once you get a robot design you think is really nice, you'll have the opportunity to switch to metal. Uh, but of course you don't have to, and it's a lot nicer to not start out with metal from the get-go.
Yeah. And then, how do you think the FTC build season timeline, usually from September to around October, November, December, how do you think that impacts the use of fabrication technologies for different teams?
Yeah, so at the beginning of the season, you're definitely going to see a lot more fully COTS robots, or say like wood or mainly 3D printed robots. But as the season keeps going, a lot more teams are going to start switching to tougher materials as their robots are more finalized. For example, at like Worlds, the main thing you're going to see is a lot of aluminum based robots because they've had the time to iterate and they've decided on a design that they think they're going to be able to win with.
Yeah, definitely. And then, what strategies do you think successful teams employ to efficiently integrate fabrication to their build process throughout the season?
Yeah, so one thing that my team definitely did is we had a team dedicated just to iterations. So they kept working on prototyping different stuff while the rest of the team, as well as them at most of the time, was creating the rest of the robot. And uh, we were just able to work on our subsystems while like all of our parts for the robot were coming in so that it all integrated really nicely. We haven't really had that many problems with that in the past. So, yeah.
Yeah, and then with challenges and problem solving, how do you or what do you suggest teams should do to approach troubleshooting and refining their components during the build season?
So, one thing I've always heard people say is if it ain't broke, don't fix it. I kind of hate that statement. If it ain't broke, just fix it. You can always iterate on it. There's never a perfect engineering pro- problem solution. uh, there's always something more you can do. So you always just want to think about it from new ways. Just keep going at it, keep getting new, fresh minds on different ideas. One thing you definitely want to look at is different, say, behind the bots and other robots presented that you see this year. And you can definitely see how they do a lot of their stuff. If you ever have any questions at a competition about how they did something, just ask. I'm sure they're going to be friendly to help out.
Yeah, definitely. And then, lastly, what advice do you have for new FTC teams regarding the use of fabrication technologies?
Yeah, so a lot of new FTC teams don't exactly have that much money to spend. Of course, they have to buy all of their electronics and robot parts. So, one thing I would recommend trying to get is a 3D printer. It will help you out a lot down the line. Even if you can't get it this season, there's a lot of new companies and stuff that have started uh, to help people get into printing and more custom parts. For example, Vertex Printing Company, they released this past summer and they've done a lot of orders for rookie teams, and it's been nice seeing how many teams have gotten into the custom game with stuff like this. For new teams, I would recommend saving some money so that down the line you might be able to get a CNC or a laser cutter. And also, if you are a school-based team, a lot of schools will have fabrication labs, and you can see if they have a laser cutter or anything. Just ask the teacher, maybe see if they can cut some wood. Yeah.
Yeah. And then, how do you think teams with limited resources should proceed with making the most of available fabrication tools? Are there any companies out there that help out new rookie teams that are struggling to find money or grants?
Yeah, so there's a lot of companies that do try to help out. For example, FabWorks, they're a metal laser cutting kind of shop. They do offer a discount to first teams. I mentioned Vertex earlier. If you apply on their website, they also give a 15% discount to any first team. So, yeah, with your rookie teams, uh, kind of just treat the season as learning. Make sure you talk with a lot of more experienced teams. I'd recommend joining the FTC Discord and kind of just hanging out there and taking in all the knowledge. That's kind of what I did.
Yeah. Davey, thank you so much for joining us today. I hope you and Arc Flash have a great season ahead.
Yeah, thank you for having me. Good luck to you guys too. Before I end, I would like to add that anyone who watched this podcast up to this point can receive 20% off any order to Vertex Printing Company using the code FABFIRST20. That's FABFIRST 20.
Thank you, everyone, for tuning into this episode of Metacast, and I hope you all have a great day. Of course, use the great code for 20% off VRTX Printing Company orders, and tune into more Metacast next week.